Greetings and welcome to this presentation on moles, relative atomic mass, and reacting masses. So without further ado, let's do! In chemistry, a mole is a unit of measurement. It is a measurement of the amount of atoms or molecules or particles within an element. In the year 1811, an Italian scientist with an operatic name of Lorenzo Romano Amedeo Carlo Avogadro brought up a principle of measuring the number of molecules, electrons, atoms, ions, etc. within an atom. Think of it like a dozen. We know that a dozen eggs would mean that there would be 12 eggs, or a score of boxes would mean there's 20 boxes. In the same way, a mole refers to a specific amount of something. However, the difference is that a mole is a really big number, exactly 602 hexillion. So if you were to say anything in moles, say a mole of apples, you would be referring to 602 hexillion apples, which is quite a lot.
Since atoms are very small, counting them one by one would be first tedious, second completely impossible. So they are grouped up in moles, where 1 mole equals to 6.02 into 10 raised to the power of 23, or 602 hexillion. This number is called the Avogadro's number or Avogadro's constant, which refers to the number of molecules or atoms within a mole. To clarify, a mole is always 6.02 into 10 raised to the power of 23. So, for example, 2 moles of potassium means 2 multiplied by Avogadro's number, which means 6.02 to 10 to the 23rd power, and the answer would show the amount of atoms or molecules present in 2 moles of potassium. When we look at the periodic table, we notice that there is the atomic number, that is the number of protons in an element. Then there is the atomic mass, the decimal number, which indicates the number of protons and neutrons in any given substance. You might have heard the terms relative atomic mass, relative formula mass, relative molecular mass, and even molar mass, but might be wondering what these actually are or what they mean. Well, relative atomic mass (RAM) and relative formula mass (RFM) are essentially the same. They refer to the atomic mass given on the periodic table. Like carbon's relative atomic mass would be 12.01 and oxygen's would be 16. These are all the masses of one atom of each element. And different elements are either heavy or light. If magnesium is 24 atomic mass units, we say magnesium is twice as more heavier than carbon. Relative molecular mass is the sum of the relative atomic masses. For instance, if you have O2 and you are to find its mass, then we know that there are 2 atoms of oxygen through the given subscript, and by the term molecular already suggests there are more than 1 atoms. We add the atomic mass of both atoms, which is 16 plus 16, giving us 32. Moving on, molar mass is like an extension of RMM. It means the mass of a compound. So if you have aluminum oxide, which is Al2 and O3, the mass of this compound would be the sum of the molecular masses of both. 2 aluminums would be 22 times 2 plus 16 times 3 for oxygen, which gives us 102. So 102 is the molar mass of the compound aluminum oxide. Do not make the mistake of considering all of them the same. They include atomic mass, but at different quantities. There might also be questions asking us to find the moles in a given mass of an element. For instance, if calcium has a mass of 120 grams, what is its mole? To find the mole, take the given mass of the element and divide it by the atomic mass of the element given on the periodic table. So here we have 120 grams of calcium, and then we divide it by calcium's atomic mass, which is given on the periodic table, that is 40, and we get 3 moles. Furthermore, the number of atoms can also be figured out. Take the mole and multiply by Avogadro's constant, and then you get the answer 1.806 into 10 to the 24th power.
An interesting way to show the magnitude of a mole would be using Toyota Corollas and how heavy they would all be if there were a mole of Toyota Corollas. One Corolla weighs 1,200 kilograms, and 602 hexillion Toyota Corollas would weigh 7.224 times 10 to the power of 26 kilograms. That would be the exact equivalent to the weight of 1.61 quintillion Burj Khalifas, as in their weight, which would be the exact same as approximately the mass of 121 Earths. Moving on to the steps of solving a reacting mass problem. Here's a very simple question, which is a reacting mass problem. And the question asks, what mass of hydrogen is needed to react with 40 grams of copper oxide? So we really only need to focus on copper oxide and hydrogen. Now there are 3 steps to follow when we solve reacting mass problems. First is from mass, the conversion from mass to moles, then is the ratio between mole to mole, and then is another conversion process from moles to masses. For the first step, we have to take the given mass of whatever element or compound there is, and then divide it by that very element or compound atomic mass, and we will get that mole, like we showed you before in last time. So 40 divided by approximately 80 would give us 0.5 moles of copper oxide. Now we have a mole, but we need to take that mole and multiply it by the ratio. We do this by using what is called the stoichiometric ratios, which is basically the calculation of relationships between reactants and products in a balanced chemical equation. We do this by looking at the coefficients and just multiplying if necessary. In this case, it is actually not necessary to multiply, as there are the same amount of moles for copper oxide and hydrogen. So we just keep 0.5 and move on to the next part. Finally, we take the 0.5 mole and multiply it by the RFM to get the mass of hydrogen that is needed to react with 40 grams of copper oxide. Hydrogen's atomic mass is 1.008, so we multiply that by 2. And you can see that we get 1.008. So we just convert it to 3 decimal places, and then we will get 1.01 grams. So now we're done. The mass of hydrogen that is needed to react with 50 grams of copper oxide is 1.01 grams. Now Praveen will show us how to do this with a bit more complex equation.
Here is a sample question with an equation. What mass of aluminum oxide is produced from 135 grams of aluminum is burned in oxygen? So here in this equation, first look at the coefficients because they determine the ratios, and write them above each element. In this case, it would be 2, 3, and 1. So given we have 135 grams of aluminum, which is the reactant, and the mass of aluminum oxide, the product, is to be found. So first, find out how much 135 grams of aluminum is in moles. Divide 135 by the atomic mass of aluminum, which is 27, and we get 5 moles. Now, find the ratio between aluminum oxide and aluminum, because it's necessary to understand how much aluminum oxide will be produced if 2 moles of aluminum reacts with 3 moles of oxygen. This means 5 into 1/2, which gives us 2.5 moles. Now find the molar mass of aluminum oxide by adding the atomic mass of each single element in this compound, that is aluminum and oxygen. So 27 times 2 because you have 2 aluminum, and 16 times 3 because you have 3 oxygens. And this equals approximately 102 atomic mass units. Multiply that with 2.5 moles and we get 255 grams, which is the mass of the aluminum.